Let's go back to our big and small problem number 1 and see if we can identify which ball, either the bowling ball or the golf ball, has the larger translational kinetic energy. My first approach at tackling this problem might be to write down the equations that describe the translational kinetic energy of the bowling ball and the translational kinetic energy of the golf ball in terms of their masses and speeds, the equations that we've seen before, 1/2 mv squared. And based upon my experience with both bowling balls and golf balls, I know that bowling balls have a larger mass than a golf ball. But in order to determine the kinetic energy of one of these balls, I need to know not only their mass, but also their speeds. And what I don't know is how does the speed of the bowling ball compare to the speed of the golf ball? Is the bowling ball moving slow and the golf ball moving fast? Or maybe the bowling ball is moving real fast and the golf ball is moving slow. Well, some information that we have is that we are told that both balls have the same non-zero linear momentum. So the linear momentum vector of the bowling ball is the same as the linear momentum vector of the golf ball. And knowing that, we can write out the linear momentum expressions in terms of the masses and velocities. And since I know that the mass of the bowling ball is larger than the mass of the golf ball, then the linear momentum relationship tells me the corresponding speed of the bowling ball must be smaller than that of the golf ball. So that gives you some information about both the mass and the speeds of the two balls. But what I don't know in this equation right here is which one of those terms, the mass term m or the speed term v, dominates. I know the bowling ball has a larger mass than the golf ball, and I also know that the bowling ball has a smaller speed than the golf ball, but I don't know if the large mass of the bowling ball and the small speed of the bowling ball is such that that gives the bowling ball more or less translational kinetic energy than the golf ball. So a better approach to take is to use the equation for translational kinetic energy that is related to the magnitude of an object's linear momentum, vector squared, divided by twice the mass of the object. And when I do that, what I'm able to do is to notice that since I'm told that the linear momenta of both the bowling ball and the golf ball are the same, then also knowing that the mass of the bowling ball is larger than the mass of the golf ball, then if p squared is the same for both balls and the mass of the bowling ball is larger than the mass of the golf ball, then the translational kinetic energy of the golf ball must be greater than the translational kinetic energy of the bowling ball. So with that idea in mind, it's readily apparent that the golf ball must have a larger translational kinetic energy than the bowling ball. We can look at another problem involving the bowling ball and the golf ball. We'll call this big and small number 2. And again, the bowling ball and the golf ball are both undergoing pure translational motion. And this time they both have the same initial non-zero linear momentum. The question we want to answer is that if we exert the same constant net force on each one of the balls, and these forces will be applied in the opposite direction of each ball's motion, which ball takes more time to stop? The bowling ball or the golf ball? Or do they both stop in the same amount of time? Or do we not have enough information to tell? Again, think about this one. We'll pause the video and get back to you with a solution.